Hey guys, Dexter here from Dexter's workshop. I was telling you some time ago, like I don't know, last week, that I will do a tutorial regarding how to program AVRs. Uh, the AVRs are a family of microcontrollers from Atmel. I'm a big fan of Atmel microcontrollers. I do like them. Not a very big fan of picks. Used them a couple of times. Didn't find them on my hand, so I stick with the Atmel for I don't know, almost 10 years now. So what you will need to correctly program an AVR, you will need a programmer. It's a piece of hardware. I recommend you, because it's very cheap, I recommend you to use USB one. I wouldn't I don't know, get complicated on using all kinds of development boards or integrated systems, because in fact what you are going to do, it's you are going to use a microcontroller and put it on the breadboard and program it and see if it works, then build a prototype and build the final product. So this is my workflow as I'm doing it. So what you will need, it's something that looks like this. It's called USBASP. I will give you the link. You will find it on eBay. It's perfect. I bought mine from eBay for $1.62 with free shipping from the Great Republic of China. So don't laugh. It's as good as anything else. It's very good. You can use it to program a lot of family of AVRs from big AVRs like 80 mega 328, or to the tiny family 80 tiny 25 45 85 13, to even to the specialized microcontroller like the CAN bus or PVM. So it's good, it's cheap, it's that cheap, it's $1.50. You can't go wrong with it. Another thing that you will need, but it's a programming cable. It's a ribbon cable. Okay, that this one, it's a 10-pin ribbon cable. Okay, it comes with the programmer. It will stick here. You cannot put it otherwise, because there's a key here, so you cannot put it in the wrong way. That's the only way you can stick it inside. And I've bought, because I really hate the 10-pin configuration. It's really dreadful. You are using only 6 pins from 10, so the other 4 are connected to the ground. I bought myself for 50 cents or 30 cents, I don't know. This adapter, it makes you to go from 10 pin to 6 pins. Okay. According to the project that you are going to do, you are going to need some wires. I'm using DuPont wires. Male. It's like this. You got male on one end and male on the other end. Okay, you will need a breadboard. I'm using this kind of breadboard. Served me for long years. It's good. It's reliable. I would not go with the very cheap ones, because inside there are some metal springs that over the years they are going to corrode or to weak, and they are not going to make a very good contact. As an example, I'm using the 80 Tiny 2313. It's a small AVR from the AVR family. Uh, it got 2 kilo of flash. Uh, you can use it for very small projects, or I don't know, some complex projects if if you are going to write the software in assembly. But I wouldn't recommend you to use it with complex projects. You don't have a lot of space inside. The peripherals are poor. You I don't know, but if I remember well, there is no I2C bus or anything like this. There is a SPI bus because all the programming it's done on SPI. So basically, this is all that you need in terms of hardware to program an AVR. I will get back to my laptop and show you how and what you are going to need in terms of software. I'm using for a very long time now Extreme Burner. Why? It's reliable. It didn't. I didn't have any problems with it, and I'm using it like 5 years now or 4 years. Um, and another thing that you are going to need is a development environment. Either you are working with the AVR Studio from Atmel that is free, or you are working with Arduino. Yes, you can use that kind of programmer with Arduino, and you can also program your software in Arduino IDE and upload it using a programmer, that kind of programmer, and you can strip away the bootloader that it's taking up to 2Ks or 4Ks depending on what AVR family you are using. So if you are going to write a piece of program or a software, and you are going to upload it using a dedicated programmer and not the Arduino serial lines, you can strip off the bootloader. You are going to gain like 2Ks of memory, which in terms of microcontrollers is pretty much. Yeah. So what I'm going to do now, I'm going to install and show you how to install it. Click, click, next, next. Extreme Burner AVR, and we are going to stick it into a free USB port, and again connect it to the microcontroller on the breadboard, and give it a test. So right now I'm gonna show you how to install Extreme Burner AVR, and I will give you also the link where you can download it. It's very easy. Practically it's next, next, click, click setup, so no configurations are necessary. Okay, so we're gonna run it. A notification message will appear that states that please make sure that USB ASP is plugged into USB before proceeding. So we are going to plug the USB programmer into an available USB port. So this one right here. Red LED will be lit. That will show you that the USB ASP it's ready to be used. Okay. Next thing, we are going to click OK. We are going to click next. Next. Create a desktop icon if you like or not. Install. So that was it. Because I had previously installed USBASP drivers. It didn't prompt me to install them again, but if you are prompted, Windows will tell you that the drivers are not signed, and if you want to install them, and click yes, install them, and then click finish. So that was it. An icon will be on your desktop here. If you are going to click it and run the program, it's pretty simple as an interface. What you have to do is choose a chip from the list. Because I'm using ATtiny 2313, I'm going to use ATtiny 2313 here. Next thing that you are going to do, it's look for the ATtiny 2313 pinout, and you'll see here on the connector, you'll see that all the pins are clearly written and clearly marked. So what you are going to do is practically connect those pins to the ones on the breadboard. I would recommend you to start connecting the pins that are not connected to the VCC, to the power line, 5 volts power line. That is going to be marked as VCC here. So you are going to connect the VCC line last, because it's better to have all the lines connected and be sure that they're connected properly. And after that, you're going to connect the power line. Okay, so what we have here, it's MOSI. MOSI. It's the violet on my configuration here. So what I'm going to do is I'm gonna look on MOSI and see that it's pin 17. That's a 20 dip package, a 20 pin dip package. So I'm going to connect MOSI to the pin number 17. So that would be 20, 18, 19, 17. There we go, here. After that, we are going to look for MISO and see MISO, it's pin 18. So MISO, it's pin 18, that is going to be 20, 19, 18. Then you are going to connect the UCSK. UCSK here, it's marked as SCK. So SCK and UCSK is the same, and you are going to connect this line to the pin number 19. So right here. Another important pin, it's the reset pin, which is going to be the pin number 1 on the package. So we are going to connect it on pin number 1 here. Oops. Okay. After that, it's the ground connection, which is pin 10. So we are going with pin 10 here. And the next one, it's the VCC connection, which is pin 20. So we are going to connect it to the pin 20 here. And that's it. That's all the connections you need to properly program an AVR. That's it. You can run a test and see if your chip is properly connected and it's properly communicating with the software and with the programmer. Here you have a small icon that it's going to read the chip information. Click it, and the chip info, it's ATtiny 2313, some other information like flash size, EPROM size, signature, and page size. Low fuses if they are present, high fuses, extended fuses, log bit, and calibration byte. Those are just some informations that are going to be used in more complex programming techniques and stuff like that. Another thing you can do and ensure that the chip is properly initialized, you can click chip erased. Erase chip. Are you sure you are going to erase the chip? Yes. And all tasks performed completed successfully. That will ensure that communication with the chip is okay and everything goes just fine. Next thing, I'm going to show you how to actually program the chip. I will write a piece of software, a very easy piece of software. It's going to it's going to blink a LED. It's like hello world of the microcontrollers programming, and I'm going to use for this. I'm going to use I'm going to use Burner AVR. You can download it from the site. It's free to use for personal purposes, and you got the limitation of 2 kilos for the program. So I'm going to be back, and after I'm going to write the software and explain a little bit, we are going to compile it and then upload it into the chip and see if everything is going to work okay. Be right back, guys. So we are back. Just wrote a piece of software that it's practically blinking a LED. It's as I told you, it's the hello world of the AVR programming, or in fact of any microcontroller. As you might see, the Bascom AVR, it's EDE. It uses syntax similar with the basic programming language, which is very easy and very common as a language. On the first line, I've defined the microcontroller that I'm going to use. The frequency of the microcontroller it's running at, it's written 1 megahertz because inside by default it came with the divide by 8 clock. So you are going to have the internal 8 megahertz divided by 8. It's 1 megahertz. So that's your real speed of the crystal. Some initialization variables are not; those are not mandatory. Then I've configured the whole port D of the AVR as the output port. I've made an infinite loop inside the do and loop, and then set port D.1, that is the pin number 3 that I've connected the LED on. Set it. It's logical 1, like plus 5 volts. Wait 500 milliseconds. Reset it. That's going back to logical 0. That's 0 volts, ideally. Wait another 500 milliseconds and redo all the instructions inside the loop. After that, what I've made, it's practically hit F7. It's compiling. Okay. No. Okay. After that, you are going to open the Extreme Burner. Click File. Click Open. Flash. You are going to choose the hex file that resulted from the previous compilation, open it, hex loaded successfully, and then you click, either you can chip erase, and I recommend you doing that. It's erase the chip before that. It's going to initialize all the flash memory, any previous errors will be erased, etc, etc. So we are going to erase the chip and click yes. All tasks completed successfully, click close, and then we are going to click the button write all, and this is going to be all tasks completed successfully. This is telling you that the program was written correctly inside the microcontroller and everything is good. As you might see, we got our LED blinking at half a second each blink. So that completes this small tutorial about how to program AVRs. So that was the tutorial regarding the AVR programming. I'm sure that if you are going to go this way and use AVRs in your projects, you are not going to use it for blinking LEDs or reading some buttons and then lit some LEDs when you are LEDs when you are pushing the buttons. I'm using them for a lot of stuff in my projects, like MIDI communications, all kind of switching of all kind of logical inside my modules and inside my my pedals or Riot Devices products. What I would recommend you to, it's choose an IDE and stick with it. It's a pretty steep learning curve with the microcontrollers, but there is no easy way. You can go either with a powerful programming language like C, or you can go directly to assembly. I wouldn't recommend you that because it's going to mash up your brains very bad. You will get very frustrated when you're going to use assembly language, because if you don't have a strong background programming and it's going to be pretty hard. But using C, if you have some background knowledge about programming, you can use C, or you can use a little intermediate IDE. It's Arduino, and it's pretty much the syntax is pretty much C. It came with with a lot of libraries and a lot of already written code. It's just practically just fitting the pieces together. You can go with BASCOM. It can be a pretty good asset if you have some really small things, some really small programs that are not critical and do not require a lot of and precise timings. Or you can go with anything. There are a lot of AVRs. Programming languages. All in all, in the end, all is translated into machine code, and all it's written inside the AVR in a machine code. So you choose what suits you best, and also what projects are you going to build. This is it, Dexter from Dexter's Workshop. It's out, and I will get back to you with some more tutorials in the next weeks. Bye bye, thank you for watching this, and I hope you learned something today. Bye guys.